Welcome to all. Today we discuss about the IO programming of 8086. First, we discuss the single bus system. First of all, what is the single bus system? So normally the 8086 is communicated with the IO devices through the system bus. The system bus is nothing but a data bus, address bus and control bus. So 8086 is interface with the external memory and IO devices. The IO devices are interface through IO port and mass storage devices. Then coming to the IO program, types of IO programming. The three types of IO programmings are in 8086. One is the programmed IO, interrupt IO and block transfer. Here, this is a program IO execution is the example of the execution programmed IO. Here, first initialize the IO devices. The IO device is nothing but a keyboard or mouse, anything. First of all, we initialize. Then is given to the input give and get the data in data register. Then the data is converted given to the CPU. That CPU is converted the hexadecimal code and the all any other operations on the byte or word. Then is transferred to the memory buffer. So that is a process is completed. Then is given to the data buffer, or otherwise is written to the data in input register. So this is a programmed IO. It's clear? Then coming to the interrupt IO programming. So interrupt IO programming is nothing but, so normally the hardwares are interrupted in 8086. Here the 8086 have a instruction pointer, code segment and program status word. Then here the interface is given. This interface is nothing but any other IO devices. First the IO devices are interfaced to the CPU. First it's send the interrupt signal to the CPU. Then the CPU's acknowledgement is written after the current instruction is completed. So the current instruction is completed, it gives the acknowledgement to the interfaces. Then the interface is identify which type of interrupt is I send to the CPU. That means a number of 3 types of interrupts are given, 4 types of interrupts are given. So type 0, type 1, type 2 and type 3. So which type of interrupt is given to the CPU, it indicates the interfaces. Then the current instruction is push on to the stack using the program status word, code segment and IP. Then interrupt flag and trap flags are cleared in the PSW, that is the program status word. The interrupt flag and trap flags are cleared. Then interrupt routine begins. The interrupt routine is given to the interrupt routine program. Whenever the start interrupt is signal is get, then interrupt is enabled. Then interrupt is continuously executed. Whenever the iReturn signal is get from the interrupt program, this signal indicates the CPU the instruction pointer, code segment and PSW to be pop-up from the stack. Then it is return is made to interrupted program. So that's all the interrupt IO programming. So normally whenever the IO devices are interfaced to the CPU, the signal is passed to the CPU. That is a request to this request sent to the CPU, and the CPU give the acknowledgement to the interface, and the current execution program is push on to the stack. Whenever the interrupt program is completed, then pop up the current execution program in the main memory. So normally this is the interrupt IO programming. The next coming to the priority to an interrupt system. So number of priorities are given in the 8086. The one is the polling, and another one is a daisy chaining, and the next one is the interrupt priority management hardware. Here, this is a daisy chaining model. Here, the bus controller have the bus request signal and bus BC signal. Here, the number of masters, each master get the services from the bus controller. The bus controller gives the bus grand signal in the master 1. Any other interrupts are requested in the bus master 1, or otherwise it's given to the next master 2. So each master or get the services from the bus controller. This is a daisy chaining. And next one is the polling. The controller sends the address of a device to grant bus access. Can use the priority resolution because the memory is the highest priority. Each master have a bus request and bus BC signal from the bus controller. Which one is the highest priority? That's the bus controller gives the bus grant to the highest priority. If does not respond, then lower priority is granted. Here the one request line and 3-bit grant lines are have in the polling type. And next, coming to the interrupt priority management hardware. Here each master has the request and grant line. Master will receive a common clock from one side and pass it to the controller, which will derive a clock for a transfer and accurately predict the calculation, since memory is always the highest priority. And this is the hardware management priority, interrupt priority. And next, coming to the block transfer functions. Here the block transfer is nothing but using DMA controller in 8086. So normally the 8086 have two signals, hold and hold acknowledgement signal. The signals are used for a DMA controller. Suppose we interface the IO devices through the 8086, through the DMA controller. First the interface is ready to receive the data from CPU, and then DMA request is made. Then the DMA is send the signal to the CPU. The CPU is get the hold signal, and it executes and it indicates the hold acknowledgement to the CPU and hold acknowledgement to the DMA controller for a bus request is made. Suppose the bus grant is returned. The bus grant is returned for a using the hold acknowledgement signal. Then the DMA device is places address on the address bus. The DMA request is acknowledged. Whenever the DMA device places on the address bus, then only it give the acknowledgement to the IO devices. Then memory places data on data buses. Then interfaces or latches the data. Then bus request is dropped and a control is returned to the 8086. And also the bus grant is dropped by the 8086. This is commonly called the block transfer. Here we directly use the directly get the data from DMA controller. That is a block transfer. Thank you.